So now let us see the various ways in which we can plot the processes, represent the processes. So suppose we have a process, cyclic process given in VT diagram. So here V and T is plotted, and we have a process like this: A, B, C, D. This is the cyclic process. First A to B, then B to C, then C to D, then D to A. So here we are interested in describing the various ways in which the same process can be represented in PT diagram, PV diagram, like this. So how we can show the processes in different variations. So the same process, suppose I have to express in PT diagram. Here pressure PT diagram. So what we use, we will write PV is equal to nRT. Now you see A to B, the process is isochoric. This is isochoric process. Isochoric process where temperature is increasing. So when the volume is kept constant, pressure is directly proportional to T. So pressure is directly proportional to T. So I will get a line that passes through the origin where I can represent my A to B. When volume is constant, so you see this is P is proportional to, so we can write P is equal to NR by V into T, where NR by V is the slope. So we can write like this. So we can have, so this is, suppose let us just first draw a rough sketch. A to B, my process is there. Then B to C, my process is that isotherm. This is isotherm. Isothermal process. Temperature is constant, so either I may go this way or that way. But you see, as the temperature is constant, as the temperature is here constant, volume is decreasing, so pressure is increasing. So actually I will go from something like this, C, and then C to D, again isochoric. So I have to come along this. So what we do, so now I know that my process will be like that. So I will draw my process from A to B like this. This is A to B. So this pressure is proportional to T because volume is constant, isochoric. Then B to C is temperature constant, B to C. Then again I will have to come through this way because here isochoric, that means from C to, I have to come like this up to A, and then again this is isotherm, temperature constant, so this is like this. So the same process which is given as VT diagram is converted into PT diagram, and this is the curve for that. Now again let us do for PV diagram. So if the same thing, either these two is given and I have to represent in PV diagram. PV diagram. This is the indicator diagram. So isochoric process. So I have taken just isochoric process like this. Suppose A to B, I have taken isochoric process. First I have to draw a rough sketch because we don't know how the graph will go like. Now B to C is a isotherm. So some isotherm will be there. So I will go from B to C something along the isotherm, and then C to D, again isochoric process. Again I have to come like this, and again D to A back. So we have an isotherm. So the process is like this. So let us draw it. So there are two isotherms. So we have two isotherms here. This is two terms. Suppose this is T2. So this is the higher. So this is higher side. So what from lower, so from A to B we are going. So A is a point here and we are going isochorically to B. So this is isochorically to B. Then B to C is a isotherm. So I am going towards C. Then C to D is again isochoric. So C to D is again isochoric, back to D we have, and D to A back to isotherm. So through the same isotherm, so we have come back. So this is the two isotherms. So this is the same process is described in PT graph and PV graph. So this is very important. So if we have if we will be given PV, we will convert into this. If this is given, we will try to convert into this. So different conversions are very, very important to understand the process and how pressure, volume and temperature of an ideal gas is related. Let us take another example. So example 2, let us take, this is I have a PV diagram now here. First I took VT diagram, now it is PV diagram. And you see here, I have a process like this in this PV diagram, and this is A, I am going towards B, then C. So this is my process, and first let us plot is PT diagram. So PV to PT diagram. So you see here, PV is equal to, I will write my nRT, this is my guiding formula. So here A to B, the volume is constant, so pressure is proportional to T. Pressure is proportional to T, so I will get something along this curve. Suppose I get A to B like this. So let us draw first a rough diagram. So next, B to C, pressure is constant. So when pressure is constant, and you see the isotherms are there and temperature is increasing, so I go this way. You see, these are the isotherms PV diagram. So C has a more temperature than B, so it is going this way, not coming this way. So A, B, C we have got. Then C to A. Now C to A, again you see, C to A something, we have this line means pressure is equal to, suppose, K times V. We will write this here. So we will put PT graph. So we will write PV as P square by K is equal to nRT. So we have P square is proportional to T. So P square is proportional to T is a parabola. So this is my parabolic path. So this is point A. I have first moved from A to B, where volume is constant. So we went along a line, then B to C where pressure is constant. So B to C I have moved along, and then through this parabolic path I have come back to A. This is a parabolic path which passes through the origin, something like this. We have parabola. You see, you recall parabola. So y square is equal to 4ax is a parabola like this, where we have y and this is x. So it passes through the origin. So here P square is proportional to T, P and T is there. So my parabola is like this. So I have to take CA path along this parabola, which passes through the origin. So this is the lines which shows that they finally actually meet at the origin. So this is how P varies with T. That is PT graph for this. Now let us see VT graph. So in order to get VT graph, I hope it is similar to this graph. Let us hope it is similar to this. So VT graph, first you start from A to B, volume is constant. So suppose I say volume is constant, that means this is A to B. Then B to C, pressure is constant. So when pressure is constant, volume is proportional to T. That means I have to move along a line passing through the origin. So I may go this way or that way. So when I am going from B to C, temperature is increasing. So I have to go this way, somewhere C. Now C to A, again you see pressure is equal to kV. So we have PV is equal to nRT and P is kV. So kV square is nRT. So again V square is proportional to T. The same thing we have to apply. So we have to again use this equation. So C to A, we have to use again the parabolic path passing through this. So what we do, so this is my parabolic path. Suppose I started with, let us go back to A to B. A to B, my path is isochoric. So I require a path from A to B like this. Then B to C, isobaric. That means I should go along a line which passes through the origin. So you see here, I have to be here up to B and then I have to go along to C, and through this C I have to come along a parabolic path which passes through the origin. So ABC. So I have to go this way. So ABC. So you see this path, how it is represented in PT and VT curve. So these transformations are very important because it tells us the functional relationship between pressure, volume and temperature and how they are plotted. So now come to another graph which is VT graph given, and let us again take a curve like this. This is VT, this is A, B and this is C. This is the process. Let us first express this process as PT graph. So if I want to express is at PT curve, so the process A to B first, let us start with P. So we will write PV is equal to nRT. Here volume is directly proportional to temperature. So P, volume is directly proportional to temperature. That means P is constant. That means P is constant. So this is a isobaric curve. So if it is isobaric, then we will write something as A to B. So you see here temperature is increasing, so it goes this way, not this way. Then B to C, isochoric. So isochoric means if V is constant, this is isochoric. That means if V is constant, P becomes directly proportional to T. That means the curve will be along a line passing through the origin. And as you see the T is decreasing, so it must come this way, decreasing way. And then C to A back through isotherm. That means it is coming through this process A, B, C. So we are going this way, coming this way and going like this. So this is isotherm graph. Now let us plot this VT graph into PV graph. So here I have pressure this way and volume this way. So first A to B isobaric. So isobaric A to B. Then B to C isochoric, with temperature decreasing. So isochoric means I can go this way, that way, but here temperature will increase. So C. Then C to A isotherm. So this is an isotherm. So I will go along the isotherm, that is the rectangular hyperbola. So ABC, this is what we have to plot in PV graph. So you can see the different plots. Now let us take one more example. Let us take this final example. We have seen so many graphs. This is again back to our indicator diagram PV graph. So again here we have A to B, B to C, C to D and D to A. So let us plot first PT diagram. So my process is isobaric. So PV is equal to, this is working formula. Isobaric process. So from A to B, I will go like this. Then isochoric, B to C. So when it is isochoric, volume is constant, my pressure becomes proportional to T. So I have to go along this line. So now B to C, the pressure is decreasing. So if I go this way, pressure will increase. So I have to come this way somewhere. Then I have again C to D as isobaric process. So I will come up to again here. I will come up to, this is C to D. So you see from C to D, the isotherms are this, temperature is decreasing, we have gone this. D to A, again volume constant, so pressure is proportional to T, we require a curve like this. So here, this type of curve we will get for same process in PT diagram. Now come to VT diagram. VT plot. So first it's an isobaric process. So again you see here, it's a isobaric process. So PV is equal to nRT. So isobaric means pressure constant. So I have volume is proportional to T. So somewhere I will have a curve along this line AB. I may have this one, but it's arbitrary AB. I don't know how curve will go. So first error of sketch. B to C, volume is constant. So from B to C, volume is constant and pressure is decreasing. So you can see from B to C, temperature is also decreasing. So B to C, its process is isochoric. So I have to go actually this way. So somewhere here I have to come. C to D, it's again isobaric. So again I have to come along this line, something, and then to some extent like this, D. And then D to A is again isochoric. So I have to go like this. So A to B, B to C, C to D, call it D here, and this is A. We can draw a better diagram this way. So this is the basic process in VT diagram, same process in PT and same in PV. So now I think we are familiar with how the process can be represented in PV, PT, VT and other type of forms.